Hello everyone, welcome back to Learn with Shirin Qazi YouTube channel. This is Sheikh Javed, and today we are going to be continuing the chapter that is Motion of Physics, grade 9. Today we are going to be learning acceleration and retardation and graphical representation of sum. What is meant by sum is स्पीड की इक्वेशंस के बारे में पढ़ेंगे. वेलोसिटी की इक्वेशंस के बारे में हम नेक्स्ट लेक्चर में पढ़ेंगे. वेलोसिटी की इक्वेशंस और यूनिफॉर्म सर्कुलर मोशन के बारे में. दिस इज़ गोइंग टू बी अ रिलेटिवली शॉर्ट लेसन since there are only 3 equations and acceleration and retardation. Okay, so let's get started. Acceleration. Acceleration is seen in non-uniform motion and it can be defined as the rate of change of velocity with time. अभी ये क्या लिखा है. डीएक्सेलरेशन की भी एक लाइन पढ़ लेता हूँ. डीएक्सेलरेशन और रिटार्डेशन is seen in non-uniform motion during decrease in velocity with time. It has same definition as acceleration. Okay, let's understand this with the help of an image. Acceleration versus deceleration. We have accelerating and we have here decelerating. What we have arrows here. Both are moving in the same direction, just the car is slowing down, thus it is trying to go back, not trying to go back, but it is slowing down its acceleration, slowing down its speed. It's the change of speed with time, change of velocity with time. Deaccelerating is just negative accelerating. Accelerating is upgrading the speed and decelerating is downgrading the speed. Same here. Okay, this was relatively simple. Now acceleration can be written as a change in velocity upon time. Now what is the change in velocity? V minus u. What is v? It is the final velocity. And what is u? What is u? It is initial velocity. Okay, and it has to be divided by time, the difference. Thus we will get acceleration. If v is greater than u, if the final velocity is greater than the initial velocity, then a will become positive. Okay, this was relatively simple. Same with deceleration or retardation. It is symbolized by this change in velocity upon time, v minus u by t. Same, but what is important here is the final velocity is less than the initial velocity. Initial velocity is always represented by u and final velocity is always represented by v. That was relatively simple, wasn't it? And now we have 3 equations of motion. First, graphical representation of equations. Distance time graph. So s by t, it is also known as s by t graph or d by t graph. Okay, this is the time and this is the distance. This straight line represents speed unit, 0 acceleration. Okay, this is a graph for uniform motion, so obviously the acceleration will not be there since acceleration is non-uniform motion. This represents the speed, this is the distance, and this is the time. What is the length of this? So S2 minus S1 upon T1 minus T2. For example, I have to get the speed in this interval of time. What will I do? S2 minus S1, distance 2 minus distance 1 upon time, that is T2 minus T1. That is just it. And what about non-uniform motion? This is non-uniform motion. As we had learned in the past lessons, it is a curve. Non-uniform motion, when represented as a graph, it is a curve. Continuous increase in slope of curvature indicates accelerated motion. Increase in slope represents accelerated motion, and continuous decrease in slope represents decelerate motion or retarded motion. That was relatively simple. Now a body at rest. So this it is a straight line. This is distance 1, distance 2, and time T1, T2. The speed will be 0 by time, that would be 0. So the body at rest would be 0. Remember that. Since there is no speed, if there was speed it would go like this, but it is going like this. Since there is no speed, so thus there is speed not there, speed will be 0. So the body at rest, this is a diagram, this is the graph for a body at rest. This was a completely short lesson. I hope you understood all of the concepts. Please like, share and subscribe.